Again from Memphis, back with a quick add-on to the Mars video and a little discussion about Betelgeuse. A quick comparison of the distances between Earth, the Moon, and Mars. The Moon averages 240,000 miles from Earth. That's approximately 1.4 light seconds. Mars can be anywhere from 35 million miles from Earth all the way out to 240 million miles, roughly 230. Let's see, the average distance of Mars from the Sun, 141 million miles. Average distance of Earth, 93 million. So Mars is on the other side of the Sun. It's about 234 million miles. Farthest point. So an average close approach from Mars would be about 47 million miles. Let's see, 48 million miles. And light at that distance, light takes roughly, just a scientific wild guess, at 186,000 miles per second. It's about 3 to 4 minutes. So 1.4 seconds versus 3 to 4 minutes. And a spacecraft traveling out to Mars takes about 7 months to get there, which is quite doable. But over here we've got Orion, a little bit higher in the sky now, so I might be able to bring out the belt. There's Rigel. Now the belt's still a little bit hard to see. Maybe it right in the middle of the screen. Yeah, there's the belt. Belt of Orion. But I really wanted to talk about tonight was Betelgeuse. I had a request to talk a little bit about Betelgeuse in a video, and I'm zoomed in here about 2.3 times. It's bringing out Betelgeuse. It's very similar in color to Mars, kind of a ruddy orange-red color. But Betelgeuse is a really cool star. It's only about 10 million years old. We think it's no older than that because it's so massive. The estimates are place it at about 20 times as massive as the Sun. With that much mass, it's burned through its hydrogen fuel reserves very quickly, so it's in the red giant phase, nearing the end of its life cycle. And so it's burning helium and other elements in its core on down to carbon, nitrogen, argon, all the way up to iron. When it gets to iron, it will have a core collapse. And when the core collapses, the Betelgeuse supernova will be the astronomical event of a lifetime. So that would be cool, but that could happen either tonight or 10,000 years from now. Nobody really knows. We're thinking it's probably sometime in the future, but it could happen. It could happen anytime. We just don't know. But based on our models of star core collapse and our observations of Betelgeuse, it could happen at any time. The distance out to Betelgeuse, we think it's about 650 light years, but it's so far out that we cannot use stellar parallax, so we don't have an accurate measurement, but as near as we can tell, it's about 650 light years away. But that estimate has varied, plus or minus several dozen light years over the past few decades. But nevertheless, it's thousands of times more luminous than the sun. I don't have the exact number in front of me. I'm going to research Betelgeuse a little bit more and do a longer, more in-depth video on it. But it's thousands of times more luminous than the sun in its red giant phase. And when it does go supernova, that will be the astronomical event of a lifetime, and that will change the appearance of Orion, which is still a really cool constellation marking the coming of winter. You can see Rigel in the right side of the screen. That's a massively bright blue star. Again, several hundred light years away, almost too far to measure with accurate parallax. I'm going to zoom in one more time, try to get the belt. Oh, there it is. There's the belt. Those stars are massive and bright as well. All the stars in Orion are much more massive and bright than the sun. And I thank you for watching.